Hello students, welcome to the session. The chapter name is integrals. Dear students, in the last video I have discussed integration using trigonometric identities. In this lecture number 8, I will continue the problems on the integration using trigonometric identities. Let us continue the same concept in this lecture. Before going to the problem section, let me recall some trigonometric formulas so that it will help us to solve the problems easily. Number 1, sin A plus sin B is equal to 2 sin of A plus B divided by 2 cos of A minus B divided by 2. This is for sin A plus sin B. This you have learnt in your PU1 in trigonometric functions chapter. Second one, sin A minus sin B is equal to 2 cos of A plus B divided by 2 into sin of A minus B by 2. Number 3, cos A plus cos B equal to 2 cos of A plus B by 2 into cos of A minus B by 2. Number 4, cos A minus cos B is equal to minus 2 sin of A plus B by 2 into sin of A minus B by 2. These are 4 formulas that you have to remember, and you have learned these all in PU1 trigonometry. Dear students, using these 4 formulas, let us extend the formulas like number 5, sin A cos B is equal to 1 by 2 square bracket sin of A plus B plus sin of A minus B. This comes from the formula number 1 that you can observe here in the RHS, sin A into cos B, taking this 2 to the left hand side, so that 1 by 2 sin of, in place of A you will write A plus B, in place of B you will write A minus B, so that you are going to get sin A into cos B is equal to 1 by 2 into sin of A plus B plus sin of A minus B. So if you understood this much, try for the second one, cos A into sin B is equal to, taking 2 to the left hand side, 1 by 2 square bracket sin of, so in place of A what I should write, A plus B, minus sin of, in place of B, A minus B, so that you get the formula of cos A sin B. Hope you understood this technique to extend the formulas. Let us see the formulas of this type. Cos A sin B equal to cos A cos B equal to, look at the right hand part here, the formula number 3, cos A cos B is equal to, taking 2 to the left hand side, 1 by 2 cos of, in place of A plus B, in place of B, A minus B, so that cos A cos B formula is 1 by 2 cos of A plus B plus cos of A minus B. Similarly, sin A sin B is equal to, taking minus 2 to the left hand side, minus 1 by 2 square bracket cos as it is, but A is A plus B minus B is A minus B. Therefore, you will get a formula of sin A sin B is equal to this much. Problem number 6. In the part lecture number 7, integration using trigonometric identities, there I have ended with the problem number 5. Here I am continuing with problem number 6. It means that the problems integration using trigonometric identities will be continue. So the first one, integration of sin 4x cos 8x dx. The solution. Purely, students, if you observe this carefully, somewhere we feel like it is in the form of sin A cos B. Look at that, sin A cos B, just A value is 4x, B value is 8x. So it means that a student who want to solve this problem must know this formula, sin A cos B. I ask you, have you studied sin A cos B formula? Definitely. Where you have studied? Just now in this session. So let us recall that. We know that sin A cos B formula 1 by 2 sin of A plus B plus sin of A minus B. So here A value is 4x, B value is 8x. Let me replace that in the formula, sin A cos B, so that you can observe formula and a value, b value. 1 by 2 sine of a plus b plus sine of a minus b. So a value 4x, b value 8x. So after writing properly, just take 1 by 2 to outside the integral. So that integration of sine 4x plus 8x is 12x. 4x minus 8x is minus 4x. Just adding and subtracting. Dear students, for this sine of minus 4x, you must know from trigonometry again, sine of minus theta is minus sine theta. So that sine of minus 4x will be minus sine 4x. So that I am going to rewrite it as I equal to 1 by 2 as it is, integration of sine 12x. As I told you, minus sine 4x comes. So plus into minus will be minus and integration of sine 4x for both the functions. So straight away go for integration. 1 by 2 integration of sine 12x minus cos 12x divided by 12 and minus as it is. Integration of sine 4x minus cos 4x divided by 4 by the list of formulas. So in the next step we get the final answer, that is I equal to 1 by 2 minus cos 12x upon 12 minus into minus will become plus and cos 4x divided by 4. Dear students, you are solving this problem. It means that already you know the integration formulas, basic integration, and with that the trigonometric identities. Then only you will be able to get it easily. Otherwise, just go back, by heart all the integration formulas, remember all the trigonometric formulas, and easily will get the problem, students. So with this, let us move into the number 7. Integration of cos 6x sin 5x dx. Again I tell you students, just treat it as cos A sin B. So to evaluate this cos 6x sin 5x, one must know cos A sin B formula. Definitely. So let us have that solution of the problem. Let me take the given problem I equal to, and we know that. Definitely I go back to the trigonometry formula, that what we discussed. Cos A sin B is 1 by 2 sin of A plus B minus sin of A minus B. Dear students, remember always this formula. So now my job is going to replace A and B value in the formula. So A value is 6x, B value is 5x. So in this entire formula I am going to write it. So that integration will be 1 by 2 sin of A plus B minus sin of A minus B. Now add the numbers here. 6x plus 5x is 11x. 6x minus 5x is x. So that we get integration of 1 by 2 sin 11x minus sin x dx. So in the next step, dear students, in the next step, let me take 1 by 2 outside the integral and taking integration for both the function, integration of 11x and integration of sin x. So straight away go back to the formulas and write the integrations here. That is 1 by 2 integration of sin 11x is minus cos 11x upon 11 and integration of sin x is minus cos x. So that we get the final answer 1 by 2 into minus cos 11x upon 11 minus into minus will become plus and cos x plus c is the final answer for integration of cos 6x sin 5x dx. I think you are slowly getting how to evaluate such problems using the formulas of trig. Dear students, why can't you try one example here? Integration of cos 6x cos 2x dx. So which kind of formula is going to apply here? Cos A cos B. Then what is cos A cos B formula? Is it 1 by 2 cos of A plus B plus cos of A minus B? Just check and write the formula. So the value of A is 6x, the value of B is 2x, writing in this formula and taking the integration with respect to x and continue the problem. Definitely will get the answer. Let me move into the next question. Number 8. After solving such examples, practicing those kind of problems, let us go back the integration using trigonometric identities. Again the formulas only, no problem. Solution. Given problem I am taking as I. Students, in this problem, definitely you come to know that this will get simplified only when you apply the proper trigonometric formula. Here what kind of formulas that you can see in the problem? 1 minus cos 2x and 1 plus cos 2x. So if you remember those formulas, fine enough. Otherwise, have a look here. We know that the formula I am taking 1 minus cos 2x upon 1 plus cos 2x, the complete fraction I am taking. In trigonometry, 1 minus cos 2x is 2 sin square x, 1 plus cos 2x is 2 cos square x. That you have studied well, and 2 and 2 will get cancelled. Sin square x upon cos square x will be tan square x. So I mean to say, overall this fraction is get replaced using trigonometric formula as tan square x. So replace that now in this I equal to integration of tan square x dx. Then a question arises, do you have integration of tan square x, the formula? No students, you don't have integration of tan square x. Then what to do? Then you have to recall a trigonometric identity, that is secant square x minus tan square x equal to 1. From this you can write tan square x. So that taking tan square to the right hand side and 1 to the left hand side, therefore tan square x is equal to secant square x minus 1. This is identity for tan square x. So your integration problem becomes tan square x can be secant square x minus 1, and integration for both secant square x as well as for 1 with respect to x. And integration of secant square x, you know the list of formulas, that is integration of secant square x is tan x, and integration of 1 with respect to x is x plus c, constant of integration. One of the very important for 2 mark just by trigonometric identities. Hope you followed. If not, let me take one more of the same type question. Number 9. Integration of 1 minus cos x upon 1 plus cos x dx. The solution. As usual, the given problem will be taken as I. Again I go back to the trigonometry so that you may understand it clearly. We know that here, just now in the previous example, 1 plus cos 2x and 1 minus cos 2x, you have replaced 1 minus cos 2x, we have replaced 2 sin square x, 1 plus cos 2x, we have replaced 2 cos square x. 2x is the angle, its half is in the RHS. 2. Then what is 1 minus cos x upon 1 plus cos x directly? Tan square x by 2. So this I will be now integration of tan square x by 2. Students, integration of tan square x we have solved by taking tan square x as secant square x minus 1 into dx, and integration of secant square x dx minus integration of 1. This we have solved in the previous problem. But now what we have? X by 2 is there. So it is not like exactly tan square x. For that reason, this one I told you. For that reason, tan square x by 2 is equal to secant square x by 2 minus 1. So I am going to replace tan square x by 2 as secant square x by 2 minus 1, taking the integration for both the function, and very important, keep this as equation number 1. Dear students, you don't have secant square x by 2 in the list of formulas of integration. You have only integration of secant square x dx as tan x. We have, so to simplify that, I am taking the substitution help, that is put t equal to x by 2 and differentiate with respect to x, that is dt by dx is equal to 1 by 2. Now I want to just replace dx. So taking dx to the right hand side, 2 to the left hand side, I want to replace only dx, so that 2 dt is equal to dx. So that given problem will be now equation 1 implies, what happens in the equation number 1? Integration of this secant square remains as it is, x by 2 will be t and dx will be 2 dt. I think you know very well about the substitution, replacement, and integration of 1 with respect to x as it is. So that taking 2 to the outside the integral, and integration of secant square t dt minus integration of 1 dx, and you know now you got integration of secant square t, that is tan t, integration of 1 with respect to x, that is x. Students, not yet completed, still you need to replace t value, so that I will be 2 tan t, I am replacing that t is nothing but x by 2, so t is nothing but x by 2 here, minus x plus c is your answer. Hope you understood. Integration of 1 minus cos x upon 1 plus cos x. By this I am going to write tan square x by 2, and tan square x by 2 by the identity again secant square x by 2 minus 1, splitting the integration for both. Here a small trick I am using, taking substitution. Even if you not take substitution also you can handle the problem, but better you take substitution. And finally we get the answer, students. Next question, number 10, integration of cos x upon 1 plus cos x dx. Students, in your earlier classes I just want to compare this problem into another problem that you have studied. Cos x divided by 1 plus sin x dx. What is the difference between this problem and this problem? Here cos x upon 1 plus cos x, here cos x upon 1 plus sin x. The difference between these two problems is, this we can consider 1 plus sin x, you can consider as substitution, because you will be getting its differentiation easily, and that is there in the integrand, so that dt is equal to cos x dx. So integration problem convert cos x dx is dt, 1 plus sin x is t. This is by substitution method, integration by substitution. When you see this question, is it like by substitution method? If you consider 1 plus cos x as t equal to 1 plus cos x, is the derivative of this function is there in the integrand? No. So try to understand the difference between the problems by substitution and by trigonometric identities formula. Trigonometric identity problems, is it by substitution or trigonometric? This is by trigonometry, not by substitution. So let us have the solution of this one. Solution, let me take the given problem I equal to as it is. Here one of the very important step I am doing because of trigonometry. To this cos x, add and subtract by 1, adding and subtracting by 1, and in the next step split it. 1 plus cos x upon 1 plus cos x is here, and one more split, 1 divided by 1 plus cos x, 1 divided by 1 plus cos x. This minus sign will be here. So why I am doing like this? I can easily cancel 1 plus cos x and 1 plus cos x, so that I get 1 in that place. So integration of 1 minus 1 upon 1 plus cos x. In the next step, integration to both the function, integration of 1 minus integration of 1 upon 1 plus cos x. Students, this you will get it easily, integration of 1 with respect to x is x. But what about this one, 1 upon 1 plus cos x? That's why I am taking, we know that a formula 2 cos square x equal to 1 plus cos 2x. 2 cos square x is 1 plus cos 2x, definitely. If I want half angle 2 cos square x by 2, then definitely it will be 1 plus cos x. Students, I tell you, be perfect in trigonometry. 2 cos square x by 2 is 1 plus cos x. Therefore, the given problem will be now I equal to integration of 1 dx minus integration of 1 upon, replacing a trigonometric formula, 1 plus cos x as 2 cos square x by 2. After that, integration of 1 dx minus, taking 1 by 2 outside the integral, and then 1 upon cos square x by 2 is secant square x by 2 by trigonometry again. This is completely trigonometry, remember that. And now integration of 1 is x minus 1 by 2 as it is. Integration of secant square x by 2 is 2 tan x by 2. Just refer the previous example. previous example, that is question number 9, there I have solved integration of secant square x by 2. Otherwise, if it is difficult for you, let me take this integration of secant square 2x just for understanding purpose. Integration of secant square is tan 2x as it is. In the denominator, x coefficient, that is 2 plus c. This is for integration of secant square 2x dx. Now I ask you, what may be integration of secant square x by 2? Directly I am asking. Directly, integration of secant square is tan this x by 2 as it is. X coefficient, what is the x coefficient here? 1 by 2, that should be in the denominator. The exact 1 by 2 should be in the denominator. In the next step, 2 will go to the numerator, therefore we get 2 tan x by 2 plus c. Therefore, integration of secant square x by 2, I am writing it as 2 tan x by 2. Hope you are understanding this question. Either you remember directly or take the help of substitution like previous example. Put a t equal to x by 2 and solve it. You will get the answer. So in the next, we are going to have the final answer, that is I equal to x minus 2 and 2 will get cancelled. So only tan x by 2 plus c comes. Hence, this is the solution of the problem. Let me go to next, number 11. Integration of sin square x upon 1 plus cos x. Again, don't think it is by substitution. It is by trigonometric formulas. How it is going to be the trigonometric formulas? Students, let me have the solution of this given problem. I equal to, we know that a standard identity sin square x plus cos square x equal to 1. From this, sin square x can be written 1 minus cos square x. Therefore, in the I, sin square x is replaced by 1 minus cos square x by the trigonometric identity. And also you should remember a formula a square minus b square, that is a plus b into a minus b. For what reason you should remember this? Here 1 I can write it as 1 square, so that comes in the form a square minus b square. Therefore, the next, if you make it square and apply a square minus b square, a plus b into a minus b, the denominator as it is. Sir, why like this? Very simple. 1 plus cos x and 1 plus cos x gets cancelled. So what is the remaining then? Only integration of, see the cancellation? Only the integration of 1 minus cos x dx. Therefore, integration of 1 and integration of cos x dx. Integration of 1 everybody knows, x. Integration of cos x, sin x. So x minus sin x plus c is the final answer. One of the very important for 2 mark. So what all happened in this question? Replacing sin square x as 1 minus cos square x, making 1 as 1 square and applying a square minus b square, then cancelling integration of 1 and integration of cos x. Integration of 1 is x, integration of cos x is sin x. So x minus sin x is the answer. Next question, students, very simple question. 12th one. Given problem will be taken as I. Let us see the next question, number 12. Integration of cos x minus sin x upon 1 plus sin 2x. Very important for 3 mark I can say, because we need more steps here. Solution. I am solving the problems on trigonometric identities means definitely I am going to use the trigonometric formulas. So for this problem, what kind of trigonometric formula is going to use? Let us have a look here. We know that, definitely we know that. I say we know that, even you also know that. Cos x plus sin x the whole square formula you recall, students. Using a plus b the whole square. A square plus b square plus 2ab. Hope you are understanding. Cos x plus sin x the whole square is cos square x plus sin square x plus 2 cos x into sin x, or 2 sin x into cos x, using a plus b the whole square formula, that is a square plus b square plus 2ab. After that, Here from trigonometry, you all know that cos x plus sin x the whole square is equal to this identity I replace sin square x plus cos square x is 1. So 1, 2 sin x cos x is sin 2x. So what you are going to get? Cos x plus sin x the whole square. Finally we arrived at 1 plus sin 2x. Hope you are understanding the reason why I am taking this formula. In the given problem of integration, we have 1 plus sin 2x. To replace this as a formula, I recalled cos x plus sin x the whole square. Not only this one, similarly, even you can have cos x minus sin x the whole square is equal to 1 minus sin 2x. If you apply a minus b the whole square formula and using the sin square x plus cos square x result, we get cos x minus sin x the whole square as 1 minus sin 2x. So now onwards, again add some formulas into your mind. 1 plus sin 2x and 1 minus sin 2x are 1 plus sin 2x is cos x plus sin x the whole square. 1 minus sin 2x is cos x minus sin x the whole square. So now I am going to have a look on this I, cos x minus sin x divided by 1 plus sin 2x into dx. So here in the denominator, I am going to replace that formula just now we got 1 plus sin 2x, that is cos x plus sin x the whole square dx. Sir, why you are taking all these formulas? Dear students, if you take the integration by substitution method, that is put t equal to the denominator cos x plus sin x only, differentiate with respect to x, dt by dx is equal to cos x differentiation is minus sin x differentiation is cos x. If you write in a reverse order, that is dt by dx equal to cos x minus sin x you will get, and taking dx to the right hand side, so dt is equal to cos x minus sin x into bracket dx. Hope you understood why I am taking this substitution. Cos x minus sin x into dx is replaced by dt, and the denominator cos x plus sin x is replaced by t. So your I will be by the method of substitution dt divided by t square. Don't forget the power t square. So integration of 1 upon t square dt is very simple. So I have taken substitution. Therefore, given I will be, as I discussed, it is going to be integration of dt upon t square, and integration of 1 upon t square is minus 1 by t plus c. Remember, integration of 1 by x square dx is equal to minus 1 by x plus c. This I have discussed in the particular cases. I think in the lecture number 2 I have discussed this. Please remember this. And now I am going to replace the t value, that is minus 1 upon t value is how much? Cos x plus sin x. So finally we arrived at the answer I equal to minus 1 upon cos x plus sin x plus c. Hope you understood. The very important task in this question is, here is the task. You must remember this. Then everything becomes simple by the method of substitution. Hope you followed. Let me go to the next 13. 13th problem is integration of cos 2x minus cos 2 alpha divided by cos x minus cos alpha dx. Solution. Before going to the integration, let me recall trigonometry. We know that cos 2x formula again, many times I am taking 2 cos square x minus 1. Dear students, here cos 2x is there, 2 cos square x minus 1. Cos 2 alpha is there, definitely 2 cos square alpha minus 1. Using this trigonometric formula, I am replacing cos 2x and cos 2 alpha by the formulas. After that, inside this minus sign into the bracket, so that we get 2 cos square x minus 1. After insiding this minus, minus 2 cos square alpha, and minus into minus will be plus 1. So after insiding minus sign, you can see minus 1 and plus 1. Are they going to cancel? Definitely. So minus 1 and plus 1 gets cancelled, and I am going to write the remaining terms. Integration of 2 cos square x minus 2 cos square alpha. In that directly I am taking 2 common. So only the remaining terms are cos square x minus cos square alpha after taking 2 common. And then 2 will be outside the integral because of constant. So, integration of cos square x minus cos square alpha upon cos x minus cos alpha. And here you understood, I think, a square minus b square form. So, the formula of a square minus b square is better to use. So, that is a plus b into a minus b. So, that I will be 2 into, if I use a square minus b square formula, a plus b into a minus b, and cos x minus cos alpha in the denominator will get cancelled. Only the remaining terms will be written. So, given I will be 2 into bracket integration of the remaining term is what in that after cancellation? Only this, because these two will get cancelled, cos x plus cos alpha, and taking the integration for both, integration of cos x dx plus integration of cos alpha dx. Students, note here, cos x is a function. So, integration of cos x is sin x. Cos alpha is a constant. Remember, this is a constant because with respect to x you are doing, cos alpha will act as a constant. Then what is the integration of cos alpha dx? Integration of cos alpha dx is cos alpha you take outside because of constant. So, integration of 1 dx. Hence, cos alpha into x you are going to get as a integration of cos alpha. Very important note that you have to concentrate. Therefore, I will be 2 into square bracket integration of cos x dx plus, as I discussed just now, taking cos alpha outside and integration of 1. Therefore, I will be 2 into integration of cos x is sin x, cos alpha remains as it is, and integration of 1 with respect to x is x. Therefore, the answer for this question is 2 into square bracket sin x plus cos alpha into x plus c. Hence, we get the solution of the problem. Hope you followed. What is the very important task? Using cos 2x formula, 2 cos square x minus 1, taking minus into the bracket and then taking 2 common. Then we get cos square x minus cos square alpha using a square minus b square. So, cancel it, take integration of cos x plus cos alpha, both side integration, treating this as constant and finally writing the answer. Hence, we get the solution. Hope you understood these all problems. Like this, some more questions are there. So, I will take those problems, integration using trigonometric identities, in the next session. Thank you, students. We will meet you in the next session with some more problems on trigonometric identities. Make sure be perfect in trigonometry as well as integration formulas.